We now consider the calculation of the expected value as well as the standard deviation. First, let's consider the expected value and the standard deviation of x. The expected value of x, the formula is you take the possible values of x and the probabilities for each. So the possible values are 1, 2, 3, 4, 5, and 6. While the possible values, or the probabilities for each of them, is 1/6. So I take the possible values and then I multiply them by the probabilities. So each of these numbers get multiplied by 1/6 because the probabilities are all the same. And then I add up these 6 products. So when I add these up, I'm essentially taking the average in this case of the numbers 1 through 6. And so just doing the calculation, I get 3.5. So that's the computation of the average. We notice that the expected value is not one of the possible values, and that is perfectly okay. That the average, the blue triangle in the picture here, is at 3.5 between the possible values of 3 and 4. To find the standard deviation, the easiest way to do this is to first figure out the expected value of x squared. Now this will be done very much the same as before, except this time I square the possible values first. 3 squared, 4 squared, 5 squared, and 6 squared. So I square all the possible values and then multiply again by the probabilities. So the possible values get squared, the probabilities do not get squared. So it's still just plain 1/6 in this expression and not 1/36. Okay, let me finish writing these down. And then we add these up and to see what the expected value of x squared is. So 1 plus 4 plus 9 plus 16 plus 25 plus 36 is 91 all over 6. And finally, the standard deviation of x, so we're not done yet, the standard deviation of x is going to be the square root of the expected value of x squared minus the mean squared. And remember, the mean is simply the expected value of x. So this is equal to the square root of 91/6 minus 3.5 squared and then we plug this into the calculator to see what we get. So 91 divided by 6 minus 3.5 squared. And then I take the square root of that. To get the standard deviation of 7078. And of course that's approximate as opposed to equal, so that's approximately equal to 4 decimal places. So that's the expected value of x. Let's now turn to the expected value of m. The calculation will be very similar. The expected value of m in this case we have 2 possible values, so -1 times 5/6 plus 4 times 1/6. The possible values are -1 and 4, and the areas, and also in this case the heights of the rectangles, tell us the probabilities associated with both of those. And so we eventually get to the expected value of m, which is -1/6. The expected value of m squared is negative 1 squared times 5/6 plus 4 squared times 1/6, paralleling what we did before. So we get 5 plus 16 makes 21/6, or 7/2. And so finally, the standard deviation of m is the square root of 7/2 minus negative 1/6 squared and plugging that into the calculator, we get a standard deviation of approximately 1.8634. Okay, now this appears in the picture. Negative 1/6 is the position of this blue triangle. That's the place where this histogram kind of balances. And we notice that 1.8634, that's slightly larger than the previous standard deviation. So even though these are have the same range, 4 minus negative 1 is 5, 6 minus 1 is 5, so the largest and the smallest values are still 5 apart. Clearly the 1 on m is more spread out, and that's indicated that the standard deviation is somewhat larger than the standard deviation for x.